Lahari, class started. Class started. Good evening, everyone. Let's start with today's class. So, today we are going to discuss the questions for week 10. I hope my voice is clear and slides are visible. So, we have already completed 9 weeks of live session for the course Industrial Biotechnology. We will be discussing a set of 12 questions for week 10. I all have attended the lectures or have gone through the lecture material and have come to the class, right? So these are the same. Have to keep yourselves mute for the audio and video throughout the session, and I will be showing you the question given a 3 minutes of time. Have to think what is the correct answer according to you, and how you have to write it down in the chat box. Okay, and keep noting down how many correct answers and how many wrong answers you all are giving. Check your score at the end of the session. Okay, and if you have any doubts, you can write down chat box. I will be looking into it. Okay, so this is clear. We'll start with today's first question. So this is from the topic bioleaching mechanism. Which of the following best differentiates direct and indirect bioleaching? Direct involves extracellular oxidants, indirect involves enzymatic attack. B. Direct involves enzymatic attack, indirect involves oxidants produced by microbes. C. Both involve enzymatic attack directly on sulfide ores. D. Direct and indirect both require ferric ions. Start answering. Okay, is everyone done? Let's see what is the correct answer to this question. It is B. Direct involves enzymatic attack, indirect involves oxidants produced by the microbes. So, what happens in the direct bioleaching? Microorganisms directly oxidize the minerals via enzymatic pathways, whereas in the indirect bioleaching, microbes regenerate the ferric ions or produce oxidizing agent, which then chemically oxidizes the roots. That's why indirect involves oxidants produced by the microbes. These microbes regenerate the ferric ions and produce the oxidizing agents, whereas in direct bleaching, directly the microorganisms oxidize the minerals. Okay, I hope this is clear. Moving on to the next question. Which microbial group plays the primary role in regenerating ferric ions during bioleaching of sulfide ores? Sulfate reducing bacteria, Thiobacillus ferrooxidans, methanogens, or D. Lactobacillus casei? Start answering. Okay, is everyone done? See what is the correct answer to this question? Is B. Thiobacillus ferrooxidans. So this is the microbial which plays an important role in regenerating ferric ions during bioleaching of sulfide ores. So this is a indirect bleaching process as we discussed in the first question. So the Thiobacillus peroxidans oxidizes Fe plus to Fe3 plus, regenerating the ferric ions essential for continuous oxidation of sulfide ores. They are the stone of industrial biology. Right? So the ones which regenerate the ions is the Thiobacillus peroxidans. So on to the next question, the first industrial copper heap leaching operation was developed in 1940s, 1950s, 1960s, or 1980s? Start answering. Okay, let's see what is the answer to this question. This was a very direct and fact-based question. It is the 1960s. So the first industrial copper leaching operation was copper heap leaching operation was developed in the 1960s. So what happened was, although the bacterial involvement in leaching was recognized in 1957, heap leaching for copper was industrialized in the 1960s. Okay, on to the next question. So this is a question. Let's see, if milk contains 3% fat and 0.88% protein with a moisture content of 35%, the approximate yield of cheese from 100 kg of milk is 5.9 kg, 7 kg, 8.3 kg, or 9.5 kg. Take a little time for this question. Solve it. The answer. Do people able to solve the question? answer only I got till now. It's doing okay. Wait 1 minute. Anyone wants to answer, they can answer. Otherwise, we'll start. Okay. Okay. Let's see what is the correct answer to this question. Right. It is B, 7 kg. Okay. So what is the formula here? Yield is equal to P factor into fat plus protein. Okay. So for the moisture content of 35%, the P factor is 1.4. You people tell me how to calculate the P factor and the adjusted fat rate. Adjusted, okay, here the explanation they have put it 2% tends to rotated. So now they have calculated like that. So the round figure is coming 7 kg. But you people have given answer as D. So which formula did you use? Tell me once. Write it down in the chat. So whoever has given the answer, what is the formula? How you have calculated that it is D. Check, check. Can anyone tell what psychology? I used those in kg. I put the percentage into kg. Anyone else? I can explain what is the explanation given, but as it is not matching with your answer, I'm asking. Even if you convert it into kg, the answer should be 7 kg or kg. Have you taken it as 3% fat? Because it should not, the fat has to be adjusted according to the Van scales formula. Okay, let me just explain it. The correct answer is 7 kg, not kg. So P factor is taken from the table. There is a table for the moisture content. So from that you can know it. There is nothing like formula for the P factor. So for the moisture content of 35%, the P factor is 1.4. Okay, I hope that is clear. Yeah, so that's where you people have done it wrong. It won't be 3 kg, it will be 2.14 kg. Let me explain that. Okay, so it is the adjusted fat. Fat is because fat in milk is given as 3%, but there is an adjustment factor which makes it to 2.14%. This is applied, the thing which is applied here is the Van Scheele's yield equation, which adjusts the fat because not all the milk fat goes into the cheese. That's why the adjustment factor is taken, and that's why the 3% becomes 2.14%. So what happens is this adjustment is based on the Van scale yield equation, where about 90% of the casein protein in milk ends up in cheese, 90%, and about 90 to 95% of fat gets trapped in the curd. So that's how it becomes from 3% to 2.14%. Is it clear? Do you people know about the Van scale equation? Van's like equation? Have you? Is it there in the material? Because I have not gone through the material in detail, so that's why I'm asking. So people must have gone into it, right? I don't know, ma'am. Then I don't know. You people have to check. I think it is there in the material. So the adjusted fat will be 2.14% and the protein will be 2.88%. Then we have to just put the values in the formula, that is yield is equal to P factor into fat plus protein, that is 1.4 into 2.14 plus 2.88. So first the bracket has to be added and then it has to be multiplied. So that's how it becomes 7.03 kg. So the correct answer is 7 kg. Okay, go through the materials once and let me know if this adjusted fat thing is included in the materials or not. If it is included, then obviously this is the correct answer. If it is not included also, this is the correct answer. I just want to know if it is present in the material or not. Okay, because accordingly you have to write the answer in your exams if this kind of question comes, right? Just go through the material once and check. If there is any doubt, let me know in the next class. Okay, we will see this question again. But the correct answer is 7 kg, not D. Okay, moving on to the next question. The key enzyme in rennet responsible for coagulating milk casein is lactase, pepsin, chymosin, lipase. Start answering. So, I don't know that girl has not joined today. Some told set of questions to ask to the NPTEL team, and one of the questions was, "What is your exam pattern? Is it only MCQs or subjective based?" Because there are a lot of numericals which can come, and you should know how to solve them and get the answer either in MCQs, or if you have to write a proper explanation for the numerical as well. But the NPTEL team responded that the exam pattern will be given few days before the exam. So they did not say anything that it will be MCQs or subjective. So have to wait. You will be getting the mail with the exam pattern details, everything. Okay. Okay, are you done? Let's see what is the correct answer to this question. It is chymosin. So the key enzyme in rennet responsible for coagulating milk casein is chymosin. So chymosin, which is also known as rennin, is the protease enzyme in rennet that cleaves K-casein, kappa casein, leading to milk coagulation. Other enzymes like pepsin and lipase are present, but they are secondary. The key enzyme is rennin or chymosin. Okay. Moving on to the next question, which type of starter culture is most robust and efficient in cheese fermentation? Single strain, multi strain, mixed strain, artisanal, natural, whey starters. Start answering. If I complete little about assignment mistakes, will it affect my internals? No, I don't think. Why will it affect your internals? But it should be brought to notice that there were some questions where the answers were given wrong, the options were wrong itself, right? But as I mailed them, they are not responding to me for any of the personal questions the students are asking. So they have only told me that you can ask the students to write it in the discussion forum. But as you all were saying that discussion forum also, you are not getting response. So yeah, sure. Only when the professor who is taking the course sees the discussion forum, they can be able to rectify it if possible. But I will just say, write down your query in the discussion. If it comes to notice, I think it taken care of. Yeah, but like this is a very unfortunate situation. But the professor should be the one to be addressing these things because they are the ones who are making current year assignments. I tried from my side as well. I mailed the NPTEL team the doubts when another girl had told me last week, Vartika. She has not joined today, but they had only replied that the students should write it in the discussion. Okay, let's see what is the correct answer to this question. It is B, multi-stream. defined mixtures. So the multi-strain starters combine defined strains, providing stability, fast resistance, and balanced acidification. So which type of starter culture is most robust and efficient? It is the multi-strain, that is the defined mixtures. These are the ones which are the most robust and efficient because they provide stability, fast resistance, and balanced acidification. On to the next question, biodiesel chemistry. It's from the biodiesel chemistry. The chemical reaction used in biodiesel production is saponification, hydrogenation, transesterification, or dehydrolysis. Okay, let's see what is the correct answer to this question. It is C, transesterification. So the biodiesel is produced by transesterification of triglycerides with methanol or ethanol in the presence of a catalyst yielding fatty acid esters and glycerol. So the biodiesel is produced by the chemical reaction called transesterification. Because then there is involvement of triglycerides with methanol or ethanol, presence of catalyst which yields the fatty acid esters and glycerol. Okay, moving on to the next question. Which catalyst type is most widely used in industrial biodiesel production? Acid catalysts, basic catalysts, enzymatic, solid heterogeneous catalysts. Start answering. Okay, let's see what is the correct answer to this question. It is B, basic catalysts. So the base catalysts dominate because they are faster, cheaper, and efficient. When free fatty acid content is low, that is less than 4%, and acid catalysis is used only for pre-treatment of high FFA oils, right? So the most widely used catalysts for biodiesel production is the basic catalysts, which include sodium hydroxide and potassium hydroxides. They are faster, they are cheaper, and they are efficient also. The next question, a fuel labeled as B20 consists of 80% biodiesel, 20% diesel, 20% biodiesel, 80% diesel, 20% biodiesel, 20% ethanol, 60% diesel, D 100% biodiesel. Start answering. Okay, let's see what is the correct answer to this question. It is B 20% biodiesel and 80% of diesel. So the biodiesel blends are represented as BX, where X is equal to percentage of biodiesel in the blend. That is B20 means 20% biodiesel, right? And rest is 80% is diesel. There is no ethanol in the biofuel. Okay, so it is 20 B20 means 20% is biodiesel and 80% is diesel. On to the next question. In acetone, butanol, ethanol fermentation, ABE fermentation, the typical solvent ratio is 6 is to 3 is to 1, 3 is to 6 is to 1 is to 3 is to 6, 2 is to 2 is to 1. Okay, let's see what is the correct answer. It is A. 6 is to 3 is to 1. The conventional ABE fermentation by Clostridium acetobutylicum yields butanol, acetone, and ethanol in the ratio 6 is to 3 is to 1. A is the correct answer, making butanol the major product. So the most proportion is the butanol, then is acetone, and then is ethanol. Okay. Moving on to the next question. Which of the following is not a typical raw material for butanol fermentation? Corn, molasses, lignocellulosic materials, methane. Start answering. Okay, let's see what is the correct answer to this question. It is D, methane. So the butanol fermentation uses starchy and sugary feedstocks like corn, molasses, and lignocellulose. But the question asks is not a typical raw material. So methane. Methane is the one which is not related, since butanol production requires fermentable carbohydrates. Carbohydrates means starch and sugar products. So methane is not that, right? Moving on to the next question. So this is the last question for today. The major difficulty in downstream recovery of biobutanol is high miscibility in water, high boiling point and low concentration in broth, gas solubility issues, lack of suitable microbial strains. Start answering. Okay, let's see what is the correct answer to this question. It is B, high boiling point and low concentration in the broth. So the major difficulty in downstream recovery of biobutanol is the high boiling point and the low concentration in the broth. So butanol concentration in the fermentation broth is nearly 20 grams per liter, while its boiling point is above 100 degrees, that is nearly 117 degrees, making distillation energy very intensive. So this is a critical bottleneck in butanol biofuel economics. Excuse me. Okay, sorry. Yeah, so this was it. So this was the last question for today. So if you have any doubts, you can ask for any of the 12 questions we have discussed today. You can tell me your scores out of 12. Okay. No one wants to share the scores out of 12. 8 out of 12. Okay. Maybe in this session, like the topics today we discussed were a little difficult for you all. That's fine. Okay. Okay, fine. No problem. All are going good. Just keep revising. We have only 2 more weeks left, 11th and 12th week to discuss. Um, Actually, backlogs. Questions. Yeah, the questions are a bit confusing. It's the I think I don't know what was your motivation behind choosing this course, but when I got this course and I checked the materials, yeah, it was a lot to study and it can be confusing for the vast and enormous lecture material available each week. I can understand. There's no option. You have already opted for this course, and anyhow, you have to pass through it, right? So just keep it up. The work. We'll meet again next week, same time. Please, everyone, join on time. Okay. Thank you, everyone.